All right, today we're going to start by talking about vectors. So a vector is some measurement that shows you both the direction and the magnitude, or how long something is. Where you start to where you end doesn't really matter. So here, all of these arrows on this plane are all the same vector because they're all going the same direction. They all have the same length. Okay, so sketching a vector. Here, if we have 2u plus v, we want to take this u vector and add another one on. You always want to add things on tip to tail. This is tip to tail. So your tip is where your arrow is, and then the tail is like the other end. So I want the tip of my first one to attach to the tail of the next one, so I'm going to draw another u vector there. So that would be 2 u's. And then I want to take this v vector and same thing, tip to tail. This is v. And then your actual resultant vector would be coming from where you originally started to where this one ended. So the blue, this would be your 2u plus v vector. And then over here, if we're going to do the same idea but subtract it, I'll add another u on here. Make it a little straighter. And then if we're going to subtract this, instead of going this direction, I'm going to go the opposite direction. So I'm going to go like this to get v, or negative v. And then you start here, and here, and this is your 2u minus v vector. All right, so writing vectors in component form. So this is listing it as their like vertical and horizontal components. So A is your horizontal, or how far you're moving in the x direction. B is how far you're moving in the y direction. So how to actually do that? So here we have 2 points, 2, 1, and -3, 4. So it starts here. So it's starting right here, that's your dot, and then ending here. So kind of like slope, you always want to take your end point minus your initial point. So to write out this vector, I'm going to take the end point x and then subtract the beginning point. And then I'm going to take the end point y, subtract the beginning point y, and then simplify this. So we get -5, +3, and that's this vector. So you don't necessarily have to have the graph as long as you know which one's your starting point, which one's your ending point. Okay, so here we want to find 3u minus 4v, and it gives us the vectors. So we're just going to distribute the 3 in. So 3u would be 3 times -2. And 5. A note here, you have to have these pointy brackets because that means it's a vector versus like a point or something else. So we want our -4 to -8. And then distribute the 3 and then 4 in. So you get -6 and 15 minus -8 and +32. Right there. And now you just want to actually, so this would be negative. Here, you can either distribute the negative in or not, so I'll leave the negative out front. And now you want to subtract here. So we're going to do -6 minus a -8 to give you -14. 15 minus -32, so it becomes plus to get 47. And this is your vector. So you could here distribute the negative in and make this positive, negative, positive, and then add them together. That's fine too. You should get the same answer. Okay, so standard unit vectors. Here, I is defined as you have 1 in the x direction and nothing else, so 0 in the y. J is nothing in the x direction and 1 in the y direction. So you can write your standard vector, or your component vector, as A, I, and Bj. So an example of that, if I have 5, -7, I can rewrite this as 5i plus or -7 And that means the same thing. Same thing like factoring or expanding. It doesn't matter which one you have. They mean the same thing. It's a different way of writing it. A note here, the magnitude of vector is the same as its length or how long it is. This is the notation, so it's not absolute value. It means magnitude, even though it looks like absolute value. How you find it. So we're going to go through this and then I'll give you the actual formula on the other slide. But if we plot this vector, say we start at 0, 0, we're going to go over 3 in the x, and then we're going to go up 5 in the y. So we get this, which then gives you a nice right triangle. So we can find this length here by doing the Pythagorean theorem. So 3 squared plus 5 squared has to equal c squared. Take the square root of both sides, and you get the square root of 3 squared plus 5 squared equals c, which then will give you square root of 34. So the magnitude is the square root of 34. So that's where the formula comes from, is the Pythagorean theorem. So if this is your vector, this is your formula to find your magnitude. If you forget, you can just do the Pythagorean theorem and it will work out. So check on Schoology for your homework, but that's it for this notes.